All right. Thanks everyone. So I won't take up too much of your time, but just give you a high-level overview of the Australian Imaging Service, which is the platform that we will be using to move the data from Royal North Shore Hospital to the University of Sydney for interim storage to facilitate analysis while at the university, and then as a way to transfer data to different universities for researchers that want to take either the reconstructed DICOM or the raw data with them. So what is AIS? It's the national platform for collaborative imaging research. It's a digital platform invested in by both the National Imaging Facility and Australian Research Data Common, offering a kind of cradle to grave service for data acquisition, patient identification, data management, analysis and pipelines, and informatics, all in one, accessed from the browser. And the idea is to bring together kind of a ecosystem of cutting edge tools that may be difficult for each individual research group to implement themselves, and bring them together as a cohesive system where researchers can trust the tools and the reproducibility. So we work as a federated model, and by that I mean we have one software code base. So everything we do is open source, free, accessible. Every university needs to bring their own compute, so to speak. So we have currently 12 nodes, and how it works is you have imaging instruments either in a hospital, in a NIF facility, in a university, what have you. They integrate with what we call an edge device. So this is something that sits on the local network near the instrument. This does the data identification, the encryption, and the routing to the university node. And then once on an AIS node, the data can be transferred between other universities. So data collected at the total body PET here can be transferred from, say, the University of Sydney to the University of Queensland AIS node. And this just provides an audited and robust way to move the data from the instruments to the final custodian of that participant's data. So at a high level, AIS is composed of 4 capability areas. So we take a data-centric computing approach. So instead of just having a high-end HPC and leaving data management to the user, we have data management at our core and bring analytics and analysis to that data management. So the first area, so a lot now, data management. So XNAT for secure collaboration, client-side visualization of DICOM data. That flows into a pipeline engine. So this is predominantly non-interactive pipelines, so where you want to do automated QC, file conversion, pre-processing, any type of bulk analysis that you want as part of the workflow during or immediately after acquisition from the instruments. And this is built on the Arcana and Pydra frameworks. The third area, which is currently in development, but will be launching later this year, is interactive analysis. So being able to provision virtual desktops, application streaming, user training, and really that whole bespoke analysis that you would do after that non-interactive pipelines. And this is particularly leveraging Jupyter Hub and partnering with the NeuroDesk project to provide a complete virtual desktop that has a whole suite of imaging tools, version controlled, built in, readily available. And the fourth, which is our kind of newest capability in development, is machine learning. So using the MONAI label framework, being able to apply a zoo of pre-trained models for AI-assisted annotation, segmentation, particularly of DICOM nifty images, and a recent MRFF that we're just starting up, being able to do federated learning. So being able to coordinate the head of the federated learning capability from the Australian Imaging Service to do machine learning right next to the instrument in the clinical site. Example of reproducible workflows. So things like file completeness check, conversion, any standard QA, any standard metrics you would want to do for your potential clinical study, along with alerts where it's not past that QA and generation of reports. So we're just kind of automating a lot of the operations around that imaging acquisition and fundamental analysis and review. So for the total body PET specifically, we have the instruments that will go through, again, we'll call it edge device. This is a data gateway that just moves the data in a secure way from the clinical environment to the university environment. So this happens on the day of acquisition. After being on the University of Sydney node, from 7 days onward, we have a data tiering system. What this allows us to do is particularly for large data, we're talking terabyte data sets, particularly with total body PET, allows us to tier the data based on usage to be able to more effectively store the data long-term from a cost perspective. And then from day 15, depending on what you're doing with the data, and I believe Jorgos would discuss that a bit later, but then we can transfer the data off the University of Sydney systems if desired or required. And there are two general approaches for this. The first is if you are a researcher at one of the Australian Imaging Service members, so the ones in production now are Neuro, Macquarie, UQ, QUT, SEMRI, WA. You'll be able to use the XNet XSync capability and directly transfer it from the USyd AIS node to yours. Monash and Newcastle are in development. If you are not one of those universities, then we'll provide an option to manually transfer and download it to your institution's long-term data storage of choice. And that mechanism may differ slightly based on where your final destination storage is. So this one's a bit technical, but just for those interested, how do we move 1 terabyte an hour from a clinical system to university system with completely different technology stacks? 1 terabyte an hour is relatively large for university. It's insanely large for most clinical workflows. So how we're doing it here is we're working with eHealth New South Wales, where they are providing a Windows virtual machine. This fits in with their normal operations and services. And then the AIS team runs a micro Kubernetes installation on that virtual machine. And then we run the secure gateway on that micro Kubernetes. So from the eHealth point of view, we're just installing a Windows application and they manage it with the normal SLA. From our point of view, we have an entire Kubernetes cluster running, albeit small, inside the clinic that allows us to do monitoring, auto-scaling, etc., and move that data to the University of Sydney AIS node on our commercial cloud Kubernetes service. And so I was talking a bit about data retention and costs. So as I mentioned, we use commercial cloud. So there are a number of different data tiers based on how fast it is to access the data. Has a cost asset. So the faster, the hotter your data is, the more expensive it is. Whereas you want to keep it long-term, but you may not interact with it, you can move it to slower or colder data storage that's much more cost-effective. So how it works on the AIS is as soon as the data comes off the instrument, it hits our AIS node on XNet. It's immediately available for download or viewing in the case of DICOM and NIFTY. And then after 7 days, where it has not been interacted with, it will tier down 1 tier, so from the red to the green. And then it's considered remotely accessible. So it may take a couple seconds to bring it back. But if you're running high-end, say machine learning directly on the node, you would need to bring it back. And then after a period of time, which is configurable per project. We can move an entire project from S3 to Glacier. So this is basically moving it from traditional hard drives to tape. And particularly, we are working on a new approach with Tollbody PET, where we can take the DICOM, the smaller data, keep that accessible, within 1 to kind of 5 second time period, but move the raw data where you want to keep that list mode, but you're not going to be really analyzing for, say, a 6-month period. And instead of waiting to archive the entire project, we can archive that raw data immediately after 7 days or a configurable time period, and then pull that data back when you're ready to analyze because you have completed your acquisition across all the patients. So this is configurable per project. And what this does is allow us to capture and store a lot more of the raw data that may want to use for research in a cost-effective way.